Good afternoon from my side. Thanks for the introduction. And first, I need to confess, obviously, I'm not Miss Lena Reinke, who was supposed to give this talk this afternoon. She's on sick leave, and she's normally our expert on all kind of photovoltaic material. And my name is Heiko Fauser. I'm the substitute for today, and please be forgiving if I'm not going too much into the details. All right, but I'm here to introduce you our adhesives or bonding technologies for flexible substrates and electronic devices. First, let me introduce the company. Maybe some of you still know us by the name of Panacol, but we had a renaming into, it was too quick, but Hoenle Adhesives, but you saw it. We already been part of the Hoenle group, as Hoenle is a manufacturer of UV curing devices or UV irradiation devices. But now we want to have a uniform market approach, so we rebranded as Hoenle. But we are still the same company, we're still the same people, still offer the same products. As you can see on the screen, this is our, company in Frankfurt, in Germany, in the heart of, or in the middle of Germany. It's a medium-sized company. We do call kind of industrial adhesives and UV curing equipment. We are roughly about 200 employees. We produce in Germany. We have R&D and application engineering here, but we have a worldwide sales distribution and technical sales. So our product portfolio is divided into several product lines. We have the vitrolids, everything around UV curing adhesives, UV curing systems. We have the structural little pine, which are 2-part and 2K and 1K adhesives, thermally curing, or the electrolytes actually electrically or thermally conductive adhesives. But today, as I mentioned, I'm going to present some adhesives meant to be designed for application of flexible photovoltaic applications. Some vitrolids we start with, so UV curing adhesives. So before we start, let us talk about UV curing or UV irradiation. I guess all of you know that UV irradiation is a part of the electromagnetic spectra ranging from roughly 100 nanometer to 400 nanometer. So actually UV light is something you want to shield your photovoltaic cells against. So maybe this offers some confusion. So here we're talking about, actually you have, you can see it in here. How can I do it on the screen? Is it possible? No, okay. Anyway, what you want, as I said, is normally you have a cover layer like PET foils or whatever above your solar cells to shield from UV light. No? And when we talk about UV irradiation here, we're talking about 4 or 5 irradiation. As we need a light source. Yeah, no, but it's not so important. If not, but thanks. Yeah, okay. So, and I'm not going to discuss this into detail, but it's just a matter of definition where UV light starts and ends. So important here is we offer 4 or 5 curing materials and 4 or 5 nanometer light sources. And for sure, we also have other equipment, but this is something you don't want on the solar cells. Now you want to block it by foils, and the curing should happen at another wavelength. So as I mentioned, now we are Hoenle altogether, and Hoenle is the producer of the UV lights, UV curing systems. You can also see an example here at the picture. So actually, here is a small mistake in the power. For sure, it's not 16,000 watt per square centimeter, it's milliwatt, but still very strong. As we offer very strong, very powerful UV curing units. We have several window outputs, it's called, or geometries. It can be like a line curing system displayed here. Can be also rectangular, circular, it's also possible. The devices are also stackable, so you can put them behind each other, whatever, to realize the radiation field you want, without gaps, with any lengths. There are air-cooled systems, as you don't need any water cooling system anymore, which makes it more intensive. And there are some experts in-house which helps you to find the right system for your application,